In this video, we're going to talk about the passage of fish. We're going to begin with the presence of the fish, which would be in the pool at Dresden Island. This is where the Dresden Lock is, and this is where the fish are currently located. Now let me give you Brandon Roads for comparison. So just keep an eye on the screen here as you see we move from Dresden Lock to Brandon Roads. So that's just a number of miles downstream. And this is the point where the Corps has been tasked with preventing the spread of aquatic nuisance species. So the fish would presumably have to make their way up the river from Dresden Plan, where they have been stalled for a number of years, I might add, and then they would have to enter this lock chamber here. If they come around the right, this dam is about 25 feet high, so there's no chance that they can move upstream through the dam. They would have to enter the lock chamber, and there is some evidence to suggest that Asian carp are reluctant to do that. But here's the point I would like to make. We are trying to estimate the passage of Asian carp from where they would be when they arrive at Brandon Roads, so that would be in this area here downstream of the lock and dam. We want to know how many, or how to describe the passage of the fish from here to Lake Michigan. So let me continue to shrink this down here, and you can see this is the journey. So when we talk about passage, we're talking about fish going from here up the waterway and into one of the 5 paths into Lake Michigan. Okay? So let's skip back over to our model here and look at how we handled that. We're going to just look at this little cluster of calculations right here. And what we have in this column would be the number of years between now and year T0. So this is 2015, and if 2021 would be year 0, then we have 6 years. All the values that are in yellow would be estimated by our experts through an expert elicitation. So here's what we would get from our experts. We would say, what is the number of fish that would pass per year through the system being Brandon Roads, Lock and Dam, and everything that is between Brandon Roads, Lock and Dam, and Lake Michigan, by year T0. And we would expect our expert to say they don't know that number and that it would be variable. So we would ask them, what would be the minimum number of fish? And in this case, this hypothetical expert said, well, it could be none. And then we would ask, what's the maximum number of fish? And then this expert would say, it could be as many as 10. So now we would like to take that interval between 0 and 10 and divide it into 4 equal pieces. So there's an equal percent of likelihood in each of those 4 segments. And what that basically means is we would ask for the first quartile value, or the 25th percentile, and they would say, well, there's a 25% chance that there are 2 or fewer fish, and there's a 75% chance that there would be 6 or fewer fish. We've used a beta general distribution, and you'll learn more about that in later courses, but for right now, let's just say this is what that distribution looks like. So it's a rather unusual looking thing, but this is what the distribution looks like. And this is an important assumption to understand, that we are making the assumption that the system from Brandon Roads, Lock and Dam to Lake Michigan will be maintained in the same consistent degree of effectiveness, or ineffectiveness if you prefer, through year T50. So for each year, year 1, 2, 3, 4, 5, 6, and continuing down here, 7, 8, 9, 10, 11, and so forth. If we go in here anywhere and we take a look at what's in there, we would see it's that very same distribution that the expert estimated. And so what we get is this. We get a total number of fish that will enter Lake Michigan in the 6 years between now and year T0. Here you see 16. But of course, it's not going to be 16. We have no idea what it's going to be. And this is just one expert's opinion, one hypothetical expert. So when I hit the recalculate button, you see it could be 24 or 18, or it could be 50 or 22. And so this value here that we're looking at is one that's uncertain. Each one of these calculations is calculating a similar number of fish. So if we have a medium population, they're pushing harder, and we would expect more fish to make it through the system. And if we have a large population, that's pushing harder still, so we would expect even more fish to get through. So our experts would have to estimate the number of fish for a small population, as you just saw. Here they estimate, whoops, excuse me, I have a meeting coming up. Here they estimate the number of fish for a medium population. And here they would estimate the number of fish for a large population. Let's take a look. Could be as few as 0, but it could be as many as 70 this time. There's a 25% chance it'll be 10 or less, a 75% chance it'll be 22 or less. And so that describes a different sort of distribution. In future videos, we'll explain the remainder of this model.